Hi, in this lecture video, I'll be doing a quick review of solution, and then we will focus on the importance of IMF in the formation of a solution. So first, what is a solution? Let's do a quick review. So we have seen already that a solution is basically a mixture consistent of two or more substances in it. And the two substances or the two components can be further classified as either a solute or a solvent. And that's what makes up a solution. And the solute are normally the substances that are present in a small amount, and typically they are normally solid or a gas. Versus the solvent would be the substance that is present in a solution in the greater amount, and normally it is a liquid. And if the solvent is a liquid, then that solution can be further classified as an aqueous solution. Whereas if the solvent is not water, then now we will call this a non-aqueous solution. And as we combine the solute and the solvent together to make a solution, then what we'll then see is that at the molecular level, the solute and the solvent are beginning to interact with each other through intermolecular force, or IMF. And so this IMF right here is really important because this is what actually determines the solubility of a solute in a particular solvent. And the different types of IMF that we have seen, a solute and solvent can make with each other on this four right here. So we can see they can either make IMF with each other through the dispersion force, or the dipole-dipole, or the hydrogen bond and the ion dipole force. So these are the four different types of IMF that are basically governance or allowing the solute and the solvent to interact with each other. And typically speaking, the stronger the IMF between the solute and the solvent, then the more soluble the solution would be. So the more soluble the solute in that solvent would be. Or we can also call this the more miscible. So the term miscible refers to how well the solute and the solvent mix together. If it produces a homogeneous solution, then we will call that a miscible solution, or the more soluble the solute in that solvent would be. And to summarize and allow us to be able to figure out whether the solute and the solvent will be able to interact strongly with each other or not, then we have this rule of thumb right here that is known as like dissolves like. And what this means is that like dissolves like means that if we were to have a polar solute, that would then dissolve in a polar solvent because they are both polar, so they're similar or they are like. Versus a non-polar solute would then dissolve in a non-polar solvent. So that's what like dissolve like mean. And the reason why that a polar solute would dissolve in a polar solvent is that they are able to make very strong IMF with each other. And we have seen already that when two molecules are polar, they could be making dipole-dipole force together or hydrogen bonding as well. But then these are the types of IMF that allow the polar solute and a polar solvent to mix with each other, interact with each other. And this is a very strong interaction. So this is why polar solute dissolve in polar solvent. And similarly, if we were to have a non-polar solute, that would then dissolve well in a non-polar solvent. And the reason why is that two things that are non-polar will be able to interact together very strongly through the dispersion force. And so that's the reason why that non-polar solute dissolve in polar solvent. If we were to have a polar molecule, a polar solute, and a non-polar solvent, then that is when they will not be able to form strong IMF with each other. So therefore, they will not dissolve well. And that is when we will have a immiscible solution. And now, let's try some practice to make sure that we are used to figuring out whether the solute and the solvent can mix with each other. And so we can make prediction whether it will be forming a miscible solution or a immiscible solution. So let's say that if we were to have a solution consistent of methanol and water, when we mix these two substances right here together, will they dissolve in each other or not? Or are they soluble? And so to be able to figure this one out, we can see that, so this molecule right here, this is a polar molecule, and it is called methanol. And this is water, which is polar as well. So now we have two substances and they are both polar. So therefore we know that they will be able to make the dipole-dipole IMF with each other. And in this case right here, hydrogen bonding as well. So therefore we see that there will be very strong IMF between these two different molecules. So therefore it will be a soluble solution or a miscible solution. And the types of IMF allow them to interact with each other. Here in this case, as we mentioned before, are H bonding and the dipole-dipole force. And now let's try another example. So let's say here in this case right here, we have this molecule and this is a hydrocarbon and its name is pentane. And in this case right here, we see this molecule right here is nonpolar. And when we mix this with water, water is a polar molecule. So because one is polar and the other one is nonpolar, they would not be able to interact together as strongly. So therefore, if we were to mix these two together, they would not dissolve in each other as well. So therefore, we will have an insoluble solution where the two substances will be separated into two layers. And this is basically very much similar to how when we combine oil and water together in a beaker, they will separate into two layers because they are not able to interact strongly with each other. So in this case, we will have an insoluble solution or an immiscible solution. And the IMF that exists between these two molecules right here will then be the dispersion force. So again, dispersion force exists in all substances. But here in this case right here, between a polar and a non-polar substance, the dispersion force between them will be pretty weak. And therefore, they're not able to bind together as well, and thus not soluble in each other. And now let's try another example. So let's say here we now have pentane, same thing. And we've seen already that this molecule right here is non-polar. And now we have ethane. And ethane is also non-polar as well. So if we were to have two non-polar molecules and we allow them to interact with each other. So in this case right here, they're similar, right? So referring to light dissolve light, we will then see they will mix with each other. And now we will have a soluble solution or a miscible solution. So that's what light dissolve light means. Polar dissolve polar and non-polar dissolve in non-polar. And in this case right here, the IMF that allow these two molecules right here to interact with each other to make them dissolve in each other would then be the dispersion force. But the dispersion force between two non-polar molecules will be pretty strong. So this is why that they're able to interact together very strongly and thus soluble in each other.